Okay, here's warm-up 10.3. When two number cubes are rolled, so a pair of dice, find the probability of rolling doubles twice in a row. So I want to find the probability of rolling doubles. I'll just put a D for that, and then rolling doubles again. Okay, so these are going to be independent events, which means that whatever happens the first time you roll the pair of dice, it doesn't affect what's going to happen on your second roll. So that means you just multiply the probability of each thing happening. All right, so rolling doubles, well, that's 6 ways to roll doubles. Double ones, double twos, threes, fours, fives, and sixes, right? And then there are 36 things that can happen when you roll 2 dice. If you use the fundamental accounting principle, it'd be first 6 things on the first die, 6 things on the second die, so 36, right? And that's going to be the same probability of rolling doubles on that second one. Now you can reduce both of these. They both reduce to 1/6. And then when we multiply straight across, we get 1 out of 36. Okay. All right, next up, find the probability of drawing a jack and then drawing a king from a standard deck of 52 cards without replacement. Okay, so this little phrase here is key because these are going to be dependent events, which means after you draw the first card out, you're not going to replace it in the deck, and that affects the probability of anything happening on the second draw because there's less cards in the deck. All right, so we got a jack and then a king. So this is, first I'm just going to find the probability of pulling out a jack, and I'm going to multiply that by the probability of pulling out a king, assuming that a jack has already been removed from the deck. Okay, all right, so probability of pulling a jack. So here's a deck of cards. There's 4 jacks in there out of the 52 cards. Okay, so there's my jacks. But then we're going to find the probability of pulling a king. Well, there's also 4 kings in the deck, but you got to assume one of the jacks has already been removed. So let's say that one has been removed. Well, then we've got we've still got 4 kings, but there's only 51 cards left. All right, and then I multiply straight across. So let's see, 52 times 51. 652, and we can definitely reduce that. So I'm just going to reduce this the quick way on my calculator. 16 divided by 2652. I'll hit enter. I'm going to go to the math menu. It's a decimal right now, but I want to change it into a fraction, so I hit math, and I'm going to choose fraction, and now it's reduced. So that's 4 over 663 reduced. Okay. Next up, Gandalf has 4 pairs of boots, 28 robes, and 10 hats. How many unique outfits does he have? Well, we can use the fundamental counting principle. We have 3 different categories here: boots, robes, and hats. And as long as Gandalf is picking one thing from each category, then we can use the fundamental counting principle. So I just think, well, how many options are there for boots? How many options for robes, and then how many options for hats, and you just multiply the number of possible outcomes in each category. And then so I'm just going to do 4 times 28 times 10, which is going to come out to 1120. Okay. All right, one more. There are 5 blue marbles and 4 red marbles in a bag. Find the probability that you randomly select a blue marble and then another blue marble without replacement. That is important. So probability of pulling a blue and then another blue. Well, these are dependent events. So I'm first just going to find the probability of pulling a blue marble. Then I'm going to find the probability of pulling another blue marble, assuming that one blue marble has already been picked and removed from the bag. Okay, so our blue marbles, there's 5 blue marbles in the bag, and there's 9 total, right? 5 plus 4 is 9. So that's the probability of pulling our first blue marble. But then on the second draw, there would only be, let's say we picked one of the blue marbles out. Now there would only be 4 blue marbles left, and there would only be 8 total marbles all together. Okay, and then I multiply this together. That gives me 20 over 72, and that's going to reduce as well to 5/18. 4 goes into both of those, and then we get 5/18. Okay, that's the end of the warm-up. See you next time.